Hey guys, welcome back to another segment of the Chemistry Digest. If you're new to this channel, please do well to subscribe, like, and turn on the notification bell for more content like this. Alright, let's learn how to do some calculations from equations. So before solving any calculation questions that involves a chemical equation, it is important to check if the equation for the reaction is balanced in order to comply with the law of conservation of matter. So, a balanced equation provides vital information about the chemical reaction. It shows us the mass of reactants required to yield a particular mass of products and what will happen if the masses are changed at any point. So, in calculation questions involving equations, we go from the normal, which is what is happening in the equation, to the what ifs, which is the question properly. Alright, let's take a look at a solved example. In this equation, we have 2 moles of magnesium atom reacting with 1 mole of oxygen gas to yield 2 moles of magnesium oxide. From all indications, the equation is balanced. That's the first step. If you don't know how to balance chemical equations, I will leave a link in the description for you to access the videos. But let me shed more light for the sake of people new to balancing equations. Alright, if you check the reactant side, which is the left hand side of the equation, you will notice that there are 2 moles of magnesium and also oxygen atom is 2, as in oxygen gas. So altogether we have 4 moles of reactant. And on the product side, it is written 2 MgO. So the 2 in front of the MgO is multiplying both the Mg, which is the magnesium, and the oxygen, which is the O. So when you isolate them, it means that we have 2 moles of magnesium combining with 2 moles of oxygen. Alright, so at the end of the day, we have 2 MgO. So when you go back to the reactant side, you are going to have 2 Mg, right? Combining with oxygen gas, which the number of oxygen there is 2. Alright, so 2 for magnesium plus 2 for oxygen will have what? 4. Alright, so that's atom count for the reactant side. So atom count for the product side will have 2 of magnesium, right, and 2 of oxygen, because the 2 in front of the MgO is multiplying both the Mg and the oxygen. All right, so doing atom counts, we are going to have 2 for Mg and also 2 for oxygen. So altogether we have 4 atoms there. So the right hand side balances with the left hand side. So after that, we go straight to the question, which is, if 12 grams of magnesium is completely bound in oxygen, what mass of magnesium oxide will be produced? So we already know what is happening in the equation. Alright, we know that 2 moles of magnesium is reacting with 1 mole of oxygen gas to give us 2 moles of magnesium oxide. They are now asking, what if we use 12 grams of magnesium? What will be the mass of magnesium oxide that will be produced? Now we can see that we have paraphrased that question and we know exactly what we are looking for. So we'll go straight to calculate the molar mass of magnesium involved in the balanced equation and also that of magnesium oxide. You can see that we also calculated the molar mass of oxygen, although we will not need it in this question. It's just for clarity purpose, because during exam conditions you just have to work with what is in the question. Alright, so after calculating their molar masses, you find out that it takes 24 grams of magnesium to react with 32 grams of oxygen gas to yield 80 grams of magnesium oxide. So what if we use 12 grams of magnesium for the reaction? What mass of magnesium oxide are we going to produce instead? So the balanced equation has given us information we need to solve this particular problem. Alright, let's continue. So we say if 24 grams of magnesium yielded 80 grams of magnesium oxide, what will 12 grams of magnesium produce? So when we do the maths, we will have that 20 grams of magnesium oxide will be the mass of magnesium oxide that will be produced. So let's solve another question. So this one says hydrogen bonds in oxygen according to the equation. 2 moles of hydrogen gas reacting with 1 mole of oxygen gas to yield 2 moles of water. So we are asked to calculate the volume of oxygen needed to react completely with 40 cm cube of hydrogen gas. So looking at the equation, we can see that it is balanced, and from the equation we can see that the ratio of combination is 2:1. That is 2 for hydrogen and 1 for oxygen. So whenever 2 volumes of hydrogen gas was used, 1 volume of oxygen gas was required. So going by the ratio 2:1, if 40 cm cube of hydrogen is the volume required for the reaction, what would be the volume of oxygen needed? So when we express that mathematically, we are going to have that the volume of oxygen gas required for this reaction to occur is 20 cm cube. So the next question says, how many moles of ammonia are produced when 6 moles of hydrogen reacts completely? So look at the equation, check if it is balanced, know what is happening in the normal equation. So from the equation, we see that nitrogen, 1 mole of nitrogen, is reacting with 3 moles of hydrogen gas to yield 2 moles of ammonia gas. Alright, so we say 3 moles of hydrogen yielded 2 moles of ammonia gas. So what will 6 moles of hydrogen gas now yield? Alright, so when we do the cross multiplication and make X the subject of the formula there, we're going to have 4 moles of ammonia. That's our final answer. Here, we are asked to calculate the mass of carbon 4 oxide, CO2, produced when 50 grams of calcium trioxocarbonate 4, CaCO3, is heated. So we start by calculating the masses of the reactant and the product to know what is going on there. Alright, so after that, we are going to realize that 100 grams of calcium trioxocarbonate 4, CaCO3, decomposes to yield 44 grams of carbon 4 oxide, which is CO2. We did not calculate the mass of CaO, which is calcium oxide, because we are not looking for it. According to the question, that is not what we are concerned with. Alright, we just calculated everything in the previous examples to give you an idea of what is going on. Alright, but here we are concerned with just CaCO3 and carbon 4 oxide. So we have it that 100 grams of CaCO3 liberated 44 grams of carbon 4 oxide. What mass of CO2 will 50 grams of CaCO3 produce? So when we do the maths, we'll have that 50 grams of CaCO3 will yield 22 grams of carbon 4 oxide. We'll end this segment by solving some questions. Make sure you drop your answers in the comment section. Until then, see you next time.